In this video, we will learn how to find out the value of the endogenous variables in a national economy. The question is given: y is equal to c plus I naught plus g naught. Y is the income, c is the consumption, I naught is the investment, g naught is the government expenditure. Consumption is equal to c naught plus b y subscript to d. That is, consumption is a positive function of disposable income, where c naught denotes the autonomous consumption when the level of income is 0. B is the moral propensity to consume, and y subscript to d denotes the disposable income, the income that is left out after paying the taxes. Here, investment is autonomous, that is exogenously given, and government expenditure is also autonomous here. And tax is, tax revenue is a function of that, a positive function of income, that is, it is related. T naught denotes the lump sum tax, and this small t denotes the marginal tax rate here. We need to find out the values of the endogenous variables here. So first thing is, what are the endogenous variables here? The variables whose value is determined within the model are called endogenous variables. And how do we find out the values here? Let me explain. Okay, so how do we solve this question? So we will use the Kramer's method here. That means we need to write the given system of equations in matrix form. So for that, let me show how to do it. So let us first write the first equation. Okay, so I have y here. So can I write y transpose this c here? Minus c is equal to I naught plus g naught. Okay, so what are the endogenous variables here? Income is the endogenous variable, consumption is the endogenous variable, this t is the endogenous variable here, and disposable income is also endogenous variable, because their values will be determined within this model. So this is first equation. Now for second equation, so since c is equal to c naught plus b y subscript to d, so let me rewrite it first. So c is equal to c naught plus b. What is disposable income? That is y minus t. Okay, or we can write c naught plus b y. What is t? T is t naught plus ty, so it will become minus t naught minus ty. Okay, so or we got c naught plus by minus bt naught minus bty. Okay, so can I rewrite it like this? So c is equal to c naught minus bt naught plus by minus bty, or we can write c is equal to c naught minus bt naught. Let us take y common here, plus y, or rather let us take b and y common. We are left with 1 minus t here. Okay, so can I rewrite it like this? So let us transpose this equation here. So we will have minus b minus b 1 minus t y. Okay, if I rewrite it here, then we have plus c is equal to c naught minus b t naught. Why I am doing this? So I want to write the system of equations in such a way that all my endogenous variables are on left hand side. Okay, c is the endogenous variable, y is the endogenous variable. These are the exogenous variables here, c naught and t naught here. Okay, that's why I have written it like this. So I have minus b 1 minus t y, then we have plus c is equal to c naught minus b t naught. Okay, in the third equation we have tax. T is equal to t naught plus ty. Since t is the endogenous variable, y is also endogenous variable. Let us transpose them. So we have ty transpose it here, it will be minus ty plus T is equal to T naught. Okay, now let me let me rub this out and let me rewrite the equations perfectly for you. Okay, or let them remain as they are here. Now I need to write the given system of equations in matrix form. That is, to solve using Cramer's rule, I need to write the system of equations in Cramer's form. Sorry, in the matrix form. That is, I write them in the form of Ax is equal to B. And let me show it here. What is A is the coefficient vector. You know, what is the coefficient of y in the first term? It is 1. The coefficient of y in the second term, we have minus B, 1 minus T. And coefficient of y in the third term is negative T. Likewise, then we have C is, okay, so the coefficient of C is negative 1. Coefficient of C in the second is positive 1. And we have no C here, so it is 0. Then the coefficient of T, since no T is involved in the first two terms, so we will have 0, 0, and the coefficient of T is here 1. So this is our coefficient matrix. X is the solution vector. What we want to find out, that is, we want to find out the value of y, c, and t. Okay, first we have y, then c, then t. So in this format we have to write the solution vector. I cannot write first y, then t, and c. So the format since we have y first, c first, then t, I have to write them in that very order. And then we have the vector of constant terms. So these are the constant terms here. We have I naught plus G naught, then we have C naught minus BT naught, then we have T naught rather. Okay, this is our and we write the system of equations in matrix form. Now we need to find out the determinant of the this matrix. This is our A. Okay, so remember, this is A, this is X, which is equal to B, Ax. So A is this very thing. Now the determinant of this will be, so how do we take determinant? We write the first element, okay, then delete the row and the column in which it appears and take the determinant of the remaining elements. So 1 ones are 1, so we will get here 1. Then we subtract and multiply these two elements, so we have minus 0. Then we write minus, okay, and then we have the second term, which is negative 1, and delete the row and the column in which it appears and take the determinant of the remaining elements. So what are the remaining elements? We have minus b, 1 minus t, okay, then we subtract and multiply these two elements, so this and this. Okay, so we have minus t into 0, which is 0. Then we write third term, which is 0, positive. So first is positive, second is negative, third is positive, and 0 times and delete the row and the column in which it appears and take the determinant of the remaining element. So we have minus b, 1 minus t, then minus from the formula, and then we have negative t into 1 is negative t. So ideally we don't need to write here, because since we have 0 here, so 0 times any determinant will be 0. Okay, so for the sake of simplicity I was trying to write it here, and let us solve it. So we have 1 minus 0 is 1, then we have minus into minus is plus 1, so we get plus 1. So we have here minus b, then we have minus b, 1 minus t. So we have 1 plus, or we have 1 minus, plus minus is minus, 1 minus b, 1 minus t, or we can write it 1 minus b, minus into minus is plus bt. Okay, this is our determinant. So determinant of A is 1 minus b plus bt. Okay, to solve using Cramer's rule, first thing is we take the determinant of the coefficient matrix. Okay, now second is to find out the value of y. What will we do to find out the value of y? And remember this, To find out the value of y, we form a new matrix A2 such that, let me repeat, to find out the value of y, what we do, we form a new matrix in such a way that we we replace the first column of the coefficient matrix with the vector of constant terms. Okay, let me repeat it here. To find out the value of y, we form a new matrix in such a way we replace the first column of the coefficient matrix with the vector of constant terms. Likewise, when we need to find out the value of c, what will we do? We will replace the second column of the coefficient matrix with the vector of constant terms. Likewise, if we want to find out the value of t, we will replace the third column of the coefficient matrix with the vector of constant terms. Okay, so first thing is first, to find out the value of y, what will we do? We form a new matrix in such a way that we replace the first column of the coefficient matrix with the vector of constant terms. So in place of I and this stuff, we write this I naught plus G naught. Then we have C naught minus BT naught. Then we have T naught. Okay, then we have all the terms same, negative 1, 1, 0, and 0, 0, 1. Then we need to find out the determinant of this matrix A2. So the determinant of A2 will be, so how do we find our determinant? We write the first term, which is I naught plus G naught. Okay, to this we delete the row and the column in which it appears and take the determinant of the remaining elements. Okay, so we are left with here 1 1s are 1 minus 0 into 0 is 0. Then we write second, so we have minus, then we have minus 1. Okay, so we have minus, then we have negative 1, and delete the row and the column in which it appears and take the determinant of the remaining element. So we have C naught minus BT naught, C naught minus BT naught. Then we have minus T naught into 0, which is 0. Then we have plus 0, third element, and delete the row and the column in which it appears and take determinant of the remaining element. So since it is 0 times the determinant of this, it will be 0. I do not need to write that very stuff here. Okay, solving further, we have I naught plus G naught. 1 minus 1 is 1, so we have 1. Then minus into minus is plus 1. Then we are left with C naught minus BT naught, C naught minus BT naught. Okay, or we can, then what will be the equilibrium value of y? So the equilibrium value of y will be equal to, that will be the determinant of new matrix divided by the determinant of the coefficient matrix. So we have A2 is this, so which is I naught plus G naught plus C naught minus BT naught. To this we divide by the determinant of the coefficient matrix, what we got, 1 minus B plus BT. Okay, having said that, now we need to find out the value of C. So for that, what will we do? To find out the value of C, we form a new matrix A2, rather A3. Ideally we should have written here A1, here A1, here also A1. Then to find out the value of C, we form a second matrix, what we call the A2. It is formed by replacing the second column of coefficient matrix with the vector of constant terms. So we have 1 negative B, 1 minus T, then minus T, then replace this with the constant terms. We have I naught plus G naught, then we have C naught minus BT naught, then we have T naught, and these terms will remain same. We have 0, 0, 1. Then we need to take the determinant of this A2. Okay, so let us see if I have the himmat that I am here. So A2, the determinant of A2, will be equal to so first we have 1 here. Okay, so we have 1. Delete the row and the column in which it appears and take the determinant of the remaining element. So we have C naught minus B T naught. Then we have minus T naught into 0, which is 0. I will not write it to save the space. Then we write the second term. So it is plus, then we have minus I naught plus G naught. Now we delete the row and the column in which it appears and take the determinant of the remaining elements. So what are the remaining elements in this case? We have minus B, 1 minus T, okay, it will not fit here. So we have yes, minus B, 1 minus T, okay, and into 1 is 1, okay. Then we subtract, so we have minus, then we have minus T times C naught minus BT naught, okay. I was sure it will get messy. Then we have plus 0, and we delete the row and the column in which it appears and multiply it with the remaining element. Wait a minute, I guess I have done a mistake here. Why? So first we have this 1, okay, and we multiply it with this determinant, that is yeah. So we have I naught. So we have first element, and we delete the row and the column in which it appears and multiply it with the remaining element. So we have C naught minus BT naught, okay. Then minus T naught into 0, which is 0, so we will not write it here. Then we have minus I naught plus G naught, okay. Then we delete the row and the column in which it appears and take the determinant of the remaining elements. So remaining elements are minus B, 1 minus T, okay. Then we have minus minus T into 0, it will become 0. Then we have this is positive, this is negative, then plus 0. We write the third element and delete the row and the column in which it appears and take the determinant of the remaining element. So 0 times the determinant of this will be 0, okay. So we will get ideally here. So we have C naught minus B T naught, okay. Then we have minus I naught plus G naught. Then we have minus B, 1 minus T, so minus into minus is plus, T into 0 is 0. Okay, you can simplify it further. I don't have the space here. Then the determinant, that is the equilibrium value of y, C will be equal to the determinant of A2 divided by the determinant of the coefficient matrix. So determinant is here C naught minus B T naught. Then we have minus into minus is plus. Let me write it here, plus B1 minus T. I am writing this term first. Then we have I naught plus G naught, and we divide it with the determinant of the coefficient matrix, which is 1 minus B plus BT. Okay. Then to find out the value of, I cannot show it here because of the lack of the space. Now to find out the value of T, what will we do? We will form a new matrix A3 by replacing the third column of the coefficient matrix with the vector of constant terms. So our new matrix will be that we have 1, then we have minus b, 1 minus t, then we have negative t, then we have negative 1, 1 and 0, negative 1, 1 and 0. Then we replace this with this. We have I naught plus g naught, I naught plus g naught, then we have c naught minus b t naught, then t naught. Okay, we form the new matrix A3. Then we take the determinant of A3, like we have taken the determinant of A2 and A1. Then T will be equal to the determinant of A3 divided by the determinant of the coefficient matrix. You can do it by yourself. I hope I made myself clear. There can be some mistakes in the calculation, so I apologize for those very things. Okay, I hope I make myself clear. Thank you.